Of a bowler. Gina rolls a bowling ball of mass 7 kilograms, m equals 7 kilograms, and radius 10.9 centimeters, which is 0.109 meters, down a lane with the velocity of 6 meters per second. Find the rotational kinetic energy of the bowling ball, assuming it doesn't slip. What is its total kinetic energy? Well, first thing I'm going to do, it's a solid bowling ball. We'll assume the mass is uniformly distributed. So I'm going to find the moment of inertia of the bowling ball by modeling it as a solid sphere. Moment of inertia for a solid sphere is 2/5 mr squared. So that'll be 2/5 times its mass, 7, times the square of its radius, 0.109 squared, or about 0.033 kilogram meters squared. Now it would be helpful to find its angular velocity. And we can do that by recognizing angular velocity is its linear velocity divided by the radius, assuming it's not slipping. And we can make that assumption. It does not slip. So that's going to be our 6 meters per second divided by its radius, 0.109 meters, or about 55 radians per second. Well, from here, let's find its rotational kinetic energy. Rotational kinetic energy is 1/2 I omega squared, or 1/2 times our I, 0.033 kilogram meters squared, times our angular velocity, 55 radians per second squared, or about 50 joules. What about its total kinetic energy? Well, kinetic energy total is going to be 1/2 mv squared plus the rotational 1/2 I omega squared, which is going to be 1/2 times our mass, 7, times the velocity, 6, squared, plus, well, 1/2 I omega squared we already said was 50 joules. So 1/2 times 7 times 6 squared, 36 plus 50. I come out with about 176 joules for its total kinetic energy, rotational plus translational. Thanks for watching Educator.com. Hopefully this gets you started with rotational motion, conservation of angular momentum, and putting that all together with rotational dynamics as well. Make it a great day. We'll see you again soon.